We have 220 subscribers. Yes! This doesn't sound like a lot to most of you on YouTube, but actually around 90% of all the views comes from subscribed users. This means I have a pretty small but amazingly engaged community. And this is what I wanted. I wanted to put out content in a kind of a niche that people actually enjoy and properly watch. So I would say goal reached, but I would love to grow this a little bit because it takes a lot of effort making these videos. So if I am able to monetize the videos, it will be much easier for me to get new equipment and get even better content for you. So please consider subscribing if you feel like it. Of course, if you don't like it, don't do it. Today we are talking about performance. I want to talk about this because nowadays that I'm the director of web development, I'm generally either on the architecture side of things or I come in later on a project if things don't go well or if there's a fire to put out, stuff like that. And I guess every project I'm on, we always have those KPIs, which are like the goals for performance. And every time our clients or our partners look into the performance, they don't really they might know, but they don't really know what to say about it. And they always point to things that we should fix that are actually kind of old school. Like nowadays, there's a lot you can do for performance that goes against the rules of the old stuff. So today we're talking about HTTP 2 and what it can do for performance over HTTP 1. So this is going to be a relatively short crash course that highlights a certain amount of things that I think are important that HTTP 2 gives us. And then we're doing a real life test in which I actually prove to you what you should do with HTTP 2 multiplexing, header compression and stuff like that to actually make it viable in your projects. Let's do this. All right, let's dive in. We are talking HTTP 2 today. That's kind of annoying, isn't it? This is like a 2000s joke, I would say. It's kind of funny. I thought I'd put it in. Why not? Okay, let's start. Basically, the things I talk about in HTTP 2 is reducing latency. So what that means is perceived speed is faster. So generally, what the amount of speed over the wire for HTTP is kind of fine to download the assets. But actually what makes your application feel slow and sluggish is the latency towards actually starting that download and when things come back from the server. So I want to talk about a couple of features today that increase the perceived speed of your website. The first one is multiplexing. That is a fancy word. But before we go into what that is, let's discuss what we used to have and then what we have now with multiplexing. So in HTTP 1, this is like in the 90s, beginning of the 90s, we had something called head offline blocking. What that means in this ugly ass graph, but it illustrates, it's what it is. Anyway, so you send a file from client to server saying, I want this CSS file. The CSS file comes back from the server. And when you actually ask for another CSS file or a JavaScript file, only then that can be sent and asked. So it's a very synchronous operation. And while you're asking for the files, the browser would actually not render anything. So you see a white screen. For that time, that was kind of fine, right? But over time, we needed to be faster. We couldn't wait for people to see something, right? If you see too much of white screen, people just leave your website. Then we had HTTP 1.1 and they came up with something called pipelining in 1997 already. So this is a long time ago. So basically what that is, you can actually see it's more parallel. So whenever you send a file, it would come back, but you can have multiple files sent in parallel. Back in the day, I guess you could send two or four to one URL. That would then be in parallel, and then if you had another URL like static.yourdomain, you could ask again. Actually, for some reason, this has had a bunch of issues. We're not going to go into why that is now, because there's a whole lot of story behind that, but it turns out that the server still had render blocking requests when the files got a little bit bigger, or when there are too many in flight, it would also not work. So even if you had the perfect implementation, it still didn't really work. So then we got HTTP 2. And there we have something called multiplexing. As you can see, this graph looks very similar to the last one, only this time all the requests can be in flight all the time, and it's a truly asynchronous implementation. So as you can see, not all of those arrows are pointing the same way, and when they come back, they can be faster or later. It doesn't matter. They can be all in flight at the same time, and this really generally helps with performance. Then the next part is header compression. So each file that you request has a metadata chunk to it. And that metadata says this is the date of creation, this is the file type, how do you want it to be cached, stuff like that. Right? So an average page has like, I guess, 80 requests if you have like a brand website or an e-commerce stuff site like that. So this is around 1400 bytes of information. If you have uncompressed raw data, these bytes spread basically over multiple packets, and so UTP packets. And there's something in UTP called slow start, which actually means you cannot send so many packets in the beginning not to saturate your connection. So what that means, based on those things, you actually have 7 or 8 round trips to make to just get that header information into the browser so it knows what to do with the files. That is a lot of back and forth to actually do such a basic task of seeing, do I get this from the cache or not, and do I understand this file type or not, stuff like that. So now that we compress those headers, they actually fit in one packet rather than 7 or 8. So the UTP slow start doesn't even start up. So you don't have all those round trips, you only have one round trip from the file to the server, and then that's it. So this is much nicer and way faster. So let's talk about bundling. This is the thing we always look at, right? So you have the people from the old school that say, and I'm one of those for a long time until recently, but what that means is you bundle your files, so you put them together, because serving one bigger file is actually faster than serving multiple small files. This is HTTP 1.1. Because we did that because the overhead of requesting a file and sending it back had a lot of like back and forward round trips needed to be able to actually load just one file. So the server side of it, the request, the DNS, all of that stuff had a lot of overhead. And so what we found out, if we bundled files together and only had to do that once, it was actually much faster in the browser to just download one thing that's a bit bigger, right? So in HTTP 1.1, bundling is by far the best practice. And in this video, I'm going to show you what it means in HTTP 2 to be bundling. Should we do it? Should we not do it? Do we have to put every npm package we have separately as a script tag because we have multiplexing? You know, so the new school people would say, we just put everything separately. And then the old school people would say, no, we have to bundle them up because it's slow. So right now, let's go over the pros and cons of bundling itself. And then after that, let's do a live test to actually see what it means. I'll get into what that is in a second. So bundling pros is clearly much faster with HTTP 1.1, even though there is this pipelining business. Also, sometimes it's easier to compress bigger text files. Why that is, let's not go into that because that's a whole different story. Then let's talk about the cons of bundling. Actually, it complicates your application a little bit. By now, we see this as normal, right? We just have a bundler and it will bundle our stuff. But actually, when I came up, we had to do that ourselves. We had to code stuff, backend code, to take the files, compress them, put them together. There's a lot of extra complication into your project. Even nowadays, with those fancy React scripts and Vue starter kits and CLIs, all of that extra complexity is actually built in. So it's more heavy on the smartness of your application, let's say. Also, it breaks the granular caching of your components. Because if you have this big file and you change only one thing, you cannot just cache the rest. You have to rebuild that file and redeliver to the user all your files. So they have to invalidate that whole file and recache everything. So that's kind of silly, right? We're so smart nowadays and we cannot actually do this properly. Also, if a file is bigger, it's slower for processing and execution. If you don't have a fast processor or a lot of memory in your device, it just takes longer to actually get the stuff, put it in memory, and execute it. And then again, it forces a cache invalidation for the whole file if you have a small update. So let's talk about what I think is a good way to check if this HTTP2 multiplexing actually work and if we still need bundlers. So this is the demo setup. I have 4 pages on a static Netlify instance. They all have a different amount of files, and all these files are different sizes. So we're checking the loading time if we either load page 1 with 1,000 JavaScript files that are only like under a kilobyte. So we're basically simulating, take every NPM package we have and we just throw it at the browser in a script tag. Then page 2 is actually 50 JavaScript files of 16.4 kilobytes. So we're basically simulating a moderate concatenation. And then page 3, 6 files of 136.6 kilobytes, simulating aggressive concatenation. And then we have page 4 with 1JS files, sorry, copy mistake, 820 kilobyte file, pretty big, right? So we're basically simulating extreme concatenation. So this is what we see a lot of the times now for HTTP 1.1, one big bundle.js. So let's have a look at the browser. Let's have a look at this. So one file loaded in 18 milliseconds. So I'm doing this clean without cache, so we might see some differences in numbers, but let's see what that means. So 6 files took 258. Try it again. Now it's 27. Okay, 50 files, 86. 1,000 files. Oh, that's clearly longer. Okay, we're at 2 seconds. So you could see that 1, 6, and 50 are very close together, and then actually 1,000 is like over 2 seconds. All right, key findings time. So even with HTTP2, concatenation shows a significant improvement over serving 1,000 separate files. So we saw that between 1, 6, or 50 files, we were around between 25 milliseconds to 100, sometimes a bit more. Loaded again, it goes a bit down. It's kind of negligible between the two. But then when you serve 1,000 separate files, there's a clear delay. It oversaturates the bandwidth, let's say. So actually, concluding after this test, it's a small test clearly, but it shows some significant things, I would say. We actually still need bundlers. We are not yet, or we might never ever be in a place where you just smack every script file of NPM you have into the browser and it just loads fast. I don't think that's going to happen. So we actually still need the bundlers. Look at this guy. We do. I love this. Okay, enough. So basically, concluding what you should do and what you can tell your clients and your colleagues. Limit the amount of concurrent streams between like 125 and 256 for your whole website, if you have HTTP and multiplexing in place. So don't go higher than this, because between different browsers you will just saturate too much. Serve modules in groups of similarity. So they should be grouped. So we do need concatenation, but they should be small enough to have this cool granular cacheability. So let's say your video player, music player, blah, 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 stuff like that is grouped. So if you do an update to one of those, you only have to update that file for the cache. And your carousel and lazy loading images media thing is separate in another group. If you don't update that, it's fine, right? So make them small enough so you can have this granular cache, but make them actually big enough to still work with HTTP 1.1. Because there are people out there with old devices or old browsers that just don't support HTTP 2, or if they have maybe a flawed implementation or something. So in the end, it's a compromise. We still need bundlers. We need to bundle things in groups that are actually small enough to cache properly and to have a nice caching strategy, but also to make sure that they still work with HTTP 1.1 without being too slow. And that's it. So it's not that hard, and it's actually very interesting to learn about these things. So now, next time, when you talk to your colleagues about performance, you can actually tell them these things. Or if your client doesn't understand this so much, or they want official documentation or stuff like that, point them to this video or reach out to me, and then we can discuss. Thanks for watching, and see you next time.